We're going to find the number of positive and negative zeros and imaginary as well. We're going to use Descartes' rule of signs. So we want to find how many possible positive solutions there are, negative solutions there are, and imaginary solutions there are. The book just might find positive and negatives, and then we have our total. Well, we look at the degree, which is 5, so that means our total should be 5. And these are just the different combinations, possible combinations that we can have. Okay, so to find the positives, all we do is look at the coefficient, so that's a 1. And we just count how many sign changes as we go from coefficient to coefficient. Is there a sign change? Yes. So there's one sign change. -2 to -1, no sign change there. -1 to +6, there is a sign change there, so second one. And from +6 to -5, there's a third sign change. And from -5 to 10, there's a fourth sign changes. So that tells me that there's 4 possible positive solutions. But if we can remember that when we take the square root of something, especially even square root of -1, we get plus or minus I. So we actually have 2 imaginary solutions. Imaginary solutions always comes in pairs. So we could have 4 possible positives, or we could have 2, like we did in our first example, and then the other 2 were imaginary, right? Or we might have 0 positives and 4 imaginary. I'm just filling in the gap of what as I drop down by 2. So positives and negatives always drop down by 2 until you get to 0 or 1, and imaginaries always fill in that gap by 2. So that's why you drop down by 2. So you could also look at example 2, extra example in McGraw-Hill, or you could look up Khan Academy, how to do Descartes' rule of signs, possible positives, negatives, and imaginary solutions, because we're still trying to get to that largest degree of 5. Now to find the negatives, what we have to do is we have to go ahead and take and plug in -1. So I'm going to rewrite, all my polynomial here, the x to the 5th, x to the 4th, and all that, and I'm plugging -1 in for all my x's. Okay, so I'm plugging in -1 in for all my x's. And what I do, plug in -1 here, -1, -1, -1, -1, and then I reevaluate what my coefficients would be. So if I plug in -1 to the 5th, that's a -1. If I plug in -1 to the 4th, that's a +1. Times a -2 is a -2. -1 cubed is a negative, times a negative is a +1. -1 squared is positive. Positive times positive is a +6. Negative times -5 is a +5, and then we have our constant plus 10. So now we count the number of sign changes here. So negative, negative, no sign change. Negative to positive, 1 sign change. No, no, no. So that means my negatives go by 1s. So 1 here, 1 here, 1 here. And that gets me my total of 5. Now say if I had a 3 or something like that, it would also decrease just like the 4 decreased by 2. Okay, but right now we just have 1, so we just fill in the gap, and we always want to get to the total. So basically what you can do is see how many times you can decrease by 2 of your positives. So I can decrease 1 time, I can go from 4 to 2 and from 2 to 0, so that means I have 3 different possibilities here, 4, 2, or 1. And then however many negatives I have, however many times I can decrease their possibilities, then I times those together, and that would give me my total possibilities. So you might want to try the extra example in McGraw-Hill or go on Khan Academy. But positives, you just count the number of sign changes, put that number in for positives, always decrease it by 2, then plug in -1 for all your x's, figure out what those coefficients are, count the number of sign changes, that's your negatives, always decrease those by 2 as well to get to your total. And imaginary always fills in the gap when you decrease by 2. For both positive and negative. So there is our answer. This graph like this would be our answer.